cumulative impacts of these things. So you've got the intelligent, you've got the excess nitrogen input, you have temperature changes, we have the Asian longhorn beetle coming in, whatever, with new browser. All of these things are being looked at mostly as single factor experiments. I mean, the warming by nitrogen saturation is one of our few forays into a multi-factor global change, climate change experiment. But all of these things interact in very interesting ways, and on the regulatory side, regulations about cumulative impacts are very poorly handled. And in part because we don't deal with it, we don't understand them quantitatively, conceptually on our science side, partly because it's a hard thing to wrap your head around, for the regulation and legislative committees to wrap their heads around. But it seems like having something about cumulative ecological impacts and socioeconomic impacts, and how that can drive management, regulation, whatever, to start dealing with cumulative and multiple interactions could be fruitful. I mean, the kinds of pieces that we've seen in the first 4 talks, when you think about putting those together and all the various changes on the systems at once, it's interesting and a little daunting.
So, Aaron, while I was sitting here listening to these talks, I wrote down global change from mechanisms to forecasts and management to regional policy. Because really, I mean, you are talking about multiple factors interacting. It is land use interacting with climate, interacting with invasive species.
But even the sort of next generation climate experiments that the Department of Energy, for example, is funding now are 2 factors, right? And that's the idea of next generation experiments, and we ought to be able to do that.
Yep.
And it seems that to move forward with sort of next generation experiments, there needs to be an effort to get a next generation of modeling. I was struck listening to your talk, Aaron, that you ended with several slides of a projection of where the woolly deluge may go, but you started your talk showing how poor the initial modeling of where it was going to go and actually how it turned out. And so, as a way to move forward, I wonder if there should be an effort to look at modeling and have better predictive power. I mean, the LTR sites have so much data. Is there a way or an effort in place to investigate how to develop more sophisticated models so that we have better predictive power and therefore can influence policy and management going forward?
There are lots of different approaches to that. I'm sure Jonathan is going to talk about some of the future scenarios modeling that after lunch. We have a parallel project that's in its last 6 months that DOE has supported for a few years, trying to improve, for example, these intelligent type models where we move beyond climate envelope models to incorporate biotic interactions as well. And this is a broader effort in the community, but it's certainly something